Hey guys, so today we're going to talk about how to solve equations with fractions in them. And while it can seem challenging, we're going to look at a technique that actually allows you to remove your fractions and make the solving process a lot quicker and easier. So I call it fraction busting. You can call it fraction removing. We're just trying to get rid of these fractions. Now, before I introduce to you the steps of fraction busting, it is a way to kind of skip a few steps. So we want to understand the process behind it. So I'm just starting with an example question, the same one as in your notes. But if we wanted to solve this equation, we would be subtracting and adding and subtracting fractions with unlike denominators. And you know, in order to do that, you need to have a common denominator. Some numbers are easy to find a common denominator, but sometimes the easiest way is just to multiply the denominators by themselves, like 3 and 5, and get 15. So you get a common denominator. Now, since it's an equation, if I wanted to multiply one side by a certain number, I'd have to multiply the other side by that number as well. So again, this is just showing you the process behind fraction busting, and then I'll teach you the quick steps. So if I want to get a common denominator here in order to manipulate and work with my fractions, I'm going to actually multiply both sides by 5 and 3 because I have to do the same thing on both sides. Now, a little distributive property would tell me I would be multiplying 2x by 5 and 3. So 5 times 3 is 15. 15 times 2 is 30. So I'd have 30x here. Now, when I get to the fractions, I'm going to take it over to the side. I'd be multiplying 2/5 by 5 over 1 and by 3 over 1. Now, you would multiply straight across. 2 times 5 is 10 times 3 is 30. Denominators, 5 times 1 times 5 is 5. And so you'd have 30 over 5 or 6. Now I want you to look at something that you'll notice is that when you start multiplying these fractions by your denominators, you're going to end up with some values of 1 that could actually cancel out. And we wouldn't have even had to multiply 30 over 5. We could do 2 times 3 is 6 and 1 times 1 is 1. So 6 over 1. So just notice that by this process, you're creating a value of 1 that could be canceled out to create 1. 5 over 5. All right, so let's keep going. We want to multiply negative 1/3 by 5 over 1 and by 3 over 1. And again, I'll multiply straight across. 1 times 5 times 3, we'd have negative 15 over 3 or negative 5. But again, in this process, notice this value of 3 over 3 that I could have canceled out to make 1, and I would have had negative 1 times 5, negative 5, 1 times 1 over 1. So this creating one whole is going to be basically the premise of fraction busting. And so by doing this process, by multiplying both sides by both of the denominators, I got a lot easier equation that can now be solved with ease. Easy two-step equation. So here's kind of the process behind it. Fraction busting just simplifies this so you don't have to multiply a ton. You can just follow some quicker steps. So these are the notes you received. I printed them in color, that way they're color-coded. So the steps are essentially the same, we're just going to condense them. So the first step is the same. You're going to multiply all terms by all of the denominators that you want to get rid of. Okay, so your terms are anything separated by addition and subtraction. And notice I said use repeat denominators only once. So if both of these were 3s, I would only need to multiply by 1 3. So in green, you see where I multiplied everything by 5 and 3. We did that the same here. Now, instead of actually multiplying them out and then canceling out values of 1, your second step is to actually cancel out those values of 1 now. So if the term does not have a denominator, there's nothing that you can create 1 with, and you'll just have to multiply those. But notice our 5s cancel here, just like they did here. Our 3s cancel out to make 1, just like they did here. So after you multiply all your terms by all of your denominators, after you can cancel out your values of 1, now you just multiply the remaining numbers. So 2 times 5 times 3, like we saw earlier, 30x. 2 times 3 is 6, and negative 1 times 5 is negative 5. And now you can see we can solve that equation a lot quicker and easier. Now, don't be surprised if your solution is a fraction because you originally started with fractions. So that is something to totally look for and understand and expect. All right, we're going to do these two examples together, and then I'm going to give you some practice problems to work with. So always go back up to these steps until you get really comfortable with the process. And I promise it'll make solving equations with fractions very easy, and you'll avoid a lot of mistakes this way. All right, so let's start with this one-step equation. So I'm going to multiply all terms by all of the denominators. My denominators are 3 and 21. So all terms, even if they are not fractions, I'm going to put 3 times 21. And this was the same as writing your multiplication out to the side and distributing it. I just showed it distributed right here. All right, now I'm going to actually use the colors of these steps. So now we're going to cancel out values that make 1. So that would be 3 over 3 and 21 over 21. Now, if there was a 3 in front of this x, you could not cancel that out because that would not be 3 over 3. That would actually just be 3 over 1 times 3, which would be 9. So you can only cancel out when you have a denominator of a number and you're multiplying by that number. All right, now we are going to multiply what is left. So we have 3 times 21 times x. So that is 63x plus 2 times 21, which is 42. And that is equal to negative 1 times 3, which is negative 3. All right, from here, we just solve the equation like normal. I'm going to try to get x by itself. So I'm going to subtract 42 from both sides. Positive 42 minus 42 is 0. We have 63x is equal to negative 45. And now our last step, we want to divide both sides by 63 to undo that multiplication. And we have x is equal to negative 45 over 63. Now, again, you might end in a fraction, but you always want to simplify if you can. Both 45 and 63 have a factor of 9. So I'm going to divide top and bottom by 9, and I'm going to get negative 5/7 as my solution. All right. So you might need to pause the video to get this written down, and we're going to move on to the next example before you do some practice on your own. I would advise you, if you haven't already, to maybe get 3 different colors so you can practice these steps while you get the hang of them. All right, so let's go to this next example. So again, multiply all terms by the denominators we want to get rid of. That's 24 and 6. And again, you're multiplying every single term by 24 and 6. The only downside to this kind of trick is that you're going to end up with larger numbers, but I would prefer larger numbers than fractions. There's less room for error. All right, so we multiplied by all of our denominators. Now let's make values of 1. So 24 over 24 would cancel. Nothing can cancel here, there's no denominator. And 6 over 6 forms 1. All right, now we multiply what's left. We have 5 times 6 times d, so that's 30d. Nothing cancels when your term is just an integer without a fraction. And so we have 1 times 24 times 6, which is 144. And that's equal to 11 times 24, which is 264. Again, larger numbers, but much easier to work with in fractions. Now again, trying to get the variable by itself, we want to undo our addition first with subtraction. All right, we create 0 here. We have 30d is equal to 120. This one will divide out evenly. When we divide by 30, 120 divided by 30 gives me 4. All right, again, pause the video and copy down these notes. Definitely glue these in your interactive notebook to help you as you study for your test. Now, I'm about to show some practice problems. I would write these practice problems down, pause the video, try to complete them by yourself or with your group, and then play the video to see if you got them correct. All right. So here are your 3 practice problems. So make sure you're able to take a second and write these down, pause the video, before you try to complete them. And again, use your notes so you can do all 3 steps in the correct order. All right, so let's see how you guys did. So on this first one, negative 2/3 x plus 5/6 equals 8. I want to get rid of my fraction so it's a lot easier. So I'm going to multiply every term by my denominators. All right, then I'm going to cancel out my values that make 1. So 3 over 3 makes 1, 6 over 6 makes 1, and nothing over here makes 1. Now I'm going to multiply what's remaining. Negative 2 times 6 is negative 12x. Plus 5 times 3, 15. And that is equal to 8 times 3 times 6, which is 8 times 18, 144. All right, now we have a lot simpler of an equation to solve. I'm going to isolate my variable. I want to get my plus 15 out of the way, so I'm going to subtract 15. I now have 0. Negative 12x is equal to negative 129. I'm sorry, that is a positive 129. All right, I'm going to divide both sides by negative 12. And we have x is equal to negative 129 over 12. Sorry, I ran into the next practice problem. So while that looks like a intense fraction, we can easily see that 120 divided by 12 would be 10. So I know I have 10 wholes, and then 9 over 12 would reduce to 3/4. So negative 10 and 3/4 is x's value. All right, let's see how you guys did on the second practice problem. So I'm going to multiply by 2, 6, and 4 to get rid of my denominators. All right, I'm going to cancel out my values that make 1, which 2 over 2 would make 1, 6 over 6 would make 1, and 4 over 4 would make 1. Now I'm going to multiply what's left. 1 times 6 times 4 is 24. Minus 5 times 2 times 4. 5 times 2 is 10, times 4 is 40y. Equals 3 times 2 times 6. 3 times 2 is 6, times 6 is 36. All right, and now I want to get y by itself. So I want to get rid of this 24. Remember, it's positive because nothing is in, there's no sign in front of it. So I'm going to subtract 24 from both sides. I have negative 40y because this cancels and makes 0. Is equal to 12. Last step, divide both sides by negative 40. We have y is equal to negative 12 over 40. There is a common factor there that we can use to simplify. They both have a factor of 4. So we can simplify y to be negative 3 over 10, negative 3/10. All right, and there's one more practice problem. I'm going to try to write what we're multiplying by kind of beside it since I ran out of room. So this goes back to your notes. You do not need to multiply by 4 times 2 times 2 times 4. All you need to multiply is by 1, 4, and 1, 2. You can do it with repeating the denominators. You're just going to get much larger numbers. So multiply every term by 4 and 2. I'm going to cancel out my values of 1. So 4 over 4, 2 over 2, 2 over 2, and 4 over 4. When I multiply what's left, I have 3 times 2, which is 6x, plus 1 times 4, which is 4. And that's equal to 1 times 4, which is 4x. There was an x there, plus 3 times 2 equals 6. All right, this one actually has variables on both sides. So remember, the first step is to get your variables on one side. I like to move the smaller variable to avoid having a negative variable. So I'm going to subtract 4x from both sides. 4x minus x is 0. I'm left with 6 is equal to 2x plus 4. Now we have a very simple two-step equation. Now again, this is a lot simpler to deal with than this equation with fractions. Subtract 4 from both sides. And now you have 2x is equal to 2. Divide both sides by 2. And x is equal to 1. Now, as you're finishing this up, you can pause the video to write these examples. Just keep in mind that this fraction busting strategy is just that. It's a strategy. It's not something you have to do. There's multiple ways to solve equations with fractions, including just working with the fractions. But it is up to you. It's another tool to add in your toolkit. And I hope that you like this method and you'll look forward to trying it and using it in the future. All right, thanks for watching.